Today, we're going to talk about concentration and how we describe concentration. There are two ways we can describe concentration. Today, we'll just go through one way, but the two ways to describe concentration are quantitatively. And if you remember from our discussion before about observations, a quantitative description of concentration would include numbers. So we use molarity in chemistry, and we will cover the quantitative description of concentration in class tomorrow. Today, we're going to discuss the qualitative description of concentration. And so when we talk about when we talk about concentration in terms of qualitative observations, what we're really looking at is color. And on the left, we have a graph from the Flint, Michigan water crisis. And this graph was in our phenomena for this unit. It shows you bottles of water taken over a period of 2 weeks. And so we actually have in this graph both quantitative and qualitative description of concentration. So you can see by the bottles that you have on the left on 115A, January 15th A, it is clear, colorless. And then January 15th B, it's a little yellow. January 16th, it's more orange. January 21st A, it's very red. January 21st B is reddish orange. And then January 30th, it's orange. And you can look at those by color, and you can see the change in color of the solutions throughout those 2 weeks. And then this graph is also great because it also gives us the concentration. In this case, it gives us micrograms per liter. And you can see the yellow bar tells us the concentration of lead in the water in those units. So this is a graph that shows both descriptions of concentration, both quantitatively with the yellow bars and qualitatively with the colors of the solution. And so you have a handout, and we're going to use it to look at these two Kool-Aid solutions. So we have Kool-Aid solution A on our left and Kool-Aid solution B on the right. And this just happens to be my favorite flavor of Kool-Aid, grape. And so we have 2 glasses of Kool-Aid. And so if we look at our table, we're going to make a claim. So I want you to turn to the person next to you or behind you, and I want you to tell them which glass of Kool-Aid you think is concentrated, A or B. And so I'll give you a moment to do that. Which one do you think is concentrated, A or B? And then now I want you to explain why. What evidence do you have to say that the one you picked is concentrated? So if you said that Kool-Aid solution B is concentrated, you would be correct. So if we were to go in and be able to see the individual particles of the Kool-Aid, the grape Kool-Aid, what it would look like in the beaker, if it's concentrated, there are more particles per unit volume. And so every little dot is a Kool-Aid particle, more Kool-Aid particles per unit volume. And so then that means that solution A is dilute. And a dilute solution has fewer Kool-Aid particles per unit volume. And so the reasoning, we can look at this, and again, this is all qualitative. We haven't made any measurements. I haven't measured out I didn't measure the volume of Kool-Aid we had in those glasses. I didn't measure the amount of grape flavoring or grape particles we had in the water. We're just looking at it qualitatively. We can see solution B is darker, solution A is lighter. So now what we're going to look at is two salt solutions. We're going to look at salt solution A and salt solution B. So I have two salt solutions. A and B. And so I want you to turn to the person next to you or in front of you, and I want you to tell them which one you think is more dilute, A or B, and give your reasoning. What is your reasoning for that answer? Which one would be more dilute, A or B? Now, if you're thinking that I just asked a trick question, you are correct. Looking at these two solutions, they're both clear and colorless. There's no color to them. So we have no way to know, looking at them qualitatively, which one is concentrated and which one is dilute. And so there are some solutions, many solutions that are colorless: hydrochloric acid, sulfuric acid, vinegar, ammonia, sodium hydroxide, many solutions we use in chemistry that are clear and colorless. And so if there is a beaker of that solution on your desk or lab bench and there's not a label with a concentration, you don't know if it's concentrated or dilute by looking at it, because you can't tell, because it's always clear and colorless. And so you would need to look at it quantitatively. That's where we got to start looking at numerical values of the concentration. So we would need to look at these two solutions and measure how many moles of, if this is sodium chloride, how many moles of sodium chloride in there per, and you can see there's about 70 milliliters per liter of solution to find the molarity. And that is something we will do tomorrow. What you're going to do next is a short little Google form to make sure that you took notes and paid attention during this lesson. And so you can get out your device and log into Schoology and go to the solution unit assignment folder, and you will find the Google form there. You may use your notes on it to complete it. And tomorrow in class, we will talk about molarity and how to quantitatively describe solutions. Have a great day.